Hi, everyone. So nice to be here today. This is actually my old stomping ground. I currently live in Miami. However, I was born, bred, and raised here in San Francisco up until just a few years ago. So here in Dogpatch is where I used to come down on Saturday and Sunday for my coffee. I used to live up on Maryland, so couldn't be more thrilled to be home. Also couldn't be more thrilled here to talk to you about what we do at Vulture here. Many of you probably don't know who Vulture is, and that's not surprising. Built by developers, for developers, and only recently started to scale our sales and marketing function. But it's a dirty little secret in the industry that we are the world's leading independent cloud compute platform with over 32 data center regions around the globe, the same scale as Amazon. But what we do differently is we are purpose-built to solve the problems of ML engineering teams. We are purpose-built to help you build, scale, and deploy world-class generative AI applications in the cloud at the lowest possible cost, the greatest possible performance, and the longest term thing for all of your enterprise needs. I couldn't be more thrilled to be here today to talk to you about the future of global enterprise application architecture for generative AI. And before we actually talk about the seminal moment that we're in right now, let's talk a little bit about where we have been in the past, because we have been through different epochs of architecture for our global enterprise applications. Now, here in San Francisco, back in the early 2000s, we had the availability of the first web application server. After many years of innovation in the web, finally, with the debut of a web application server, enterprises were able to rethink how to displace old application architecture, client-server application architectures, and start modernizing and building a new library of web applications that they could scale around the globe. In this earlier epoch, we learned how to set up build environments, and test environments, and production deployment environments with compute capacity at the edge via CDNs to cache our content. And this was a wave of innovation that proceeded over the course of 10 years and led to some fun times here in Dogpatch. Roll the clock forward, early 2000s, we had the debut of a new architectural style, a RESTful architectural style. With the debut of this RESTful architectural style, people started taking the availability of low-cost compute provisioned by Amazon in EC2 instances and started to rethink how to build new types of applications, new modular application frameworks to start powering a mobile social revolution. In this epoch, we had to relearn how to set up, build, test, and deployment environments and new CI/CD pipelines, and also upgrade compute infrastructure at the edge so we could have more processing power to power a new generation of mobile applications for a new generation of consumers around the world that actually had smartphones. Now we are at a new digital frontier, because in the next decade, we have a new epochal shift in enterprise application architectures brought on most recently by the debut this past March of the NVIDIA H100. Many years of innovation in data science, many years of innovation in machine learning and artificial intelligence, and suddenly we had the processing power to actually make this revolution a reality for every single enterprise around the globe. Just like in prior decade-long architectural shifts, web application server with the RESTful architectural style, we are entering a new age of enterprise application architecture where we are, for the very first time, changing the actual basis of compute power, because now it's no longer going to be CPU-based. We have a change where now GPUs are going to be at the core of the enterprise application stack, because every single web application is going to be rebuilt and is going to be a generative AI application with LLMs at the core, with data science at the core. Remember, 10 years ago, we got excited about data-driven marketing, data-driven this, data-driven that. Did we really make good use of the data? I would argue not. We never made personalization a reality. We never made good use of the data. And the reason is because we didn't understand the data. Now we actually have the processing power. Now we actually have the algorithms to actually make sense of the data using the power of the machine. And we can actually make personalization a reality. We can actually rebuild every single consumer and enterprise experience, because now we can actually put the GPU at the core to do the work that needs to get done. This is a decade-long shift. And in the shift, like in prior shifts, we need to fundamentally set up the build environments, the test environments, the production deployment environments for inference. We need to set up the CI/CD pipelines, and we need to actually go even further to the edge to bring processing power for inference to the edge. Because if you're in Mumbai on your smartphone, when you're accessing your mobile app, it makes no sense. No sense for every single request to have to round trip to Santa Clara. We have a large-scale H100 training cluster in the Colo facility down there to have your server request fulfilled. Makes no sense at all. A new architecture is needed. It's a decade-long shift. I couldn't be more excited. Now, with the debut of the H100, suddenly everyone realized, oh my goodness, with ChatGPT, now this raw horsepower, I can actually use my enterprise data and I can do something amazing. But the challenge was, with this new enterprise architecture, your entire data center, all of your data center operations were not set up for it. How do you, first of all, secure the GPU? There was a scarcity, there was a shortage. How do you get the floor space? There was a scarcity and a shortage. How do you get the networking? There was a scarcity and a shortage. How do you get the new types of storage that you need? There was a scarcity and storage. And suddenly what people realized is actually procuring and setting up and configuring the large-scale training environments needed to unlock the power of this shift, these new chips, was nearly impossible. It was impossible here in the San Francisco Bay Area, where the vast majority of those chips were deployed, again, in a Colo center in Santa Clara. I travel all around the world. We operate in 32 regions. I will tell you what it was like in London, in Amsterdam, in Singapore, in Sao Paulo, in Mexico City, and a dozen or 24 other cities around the globe. They had zero access. Zero. Could not get a hold of anything, which is terrible, actually, I would say. So what you saw then is a mad rush for people all around the globe to try to find inventory of these things in the cloud. Because it was hard to reconfigure their data centers, because it was hard to get the floor space, because it was hard to get the power, because it was hard to get the networking, they wanted to go to cloud service providers like Vultr to say, how can I rent this GPU so I can get started, because I don't have access to getting these things here in London, but can I rent it from you somewhere else in the cloud? Now, this gave massive time to market advantages for people that could get access to cloud GPUs, because all the pain and complexity of the procuring and the provisioning and the configuring all went away. But it was simply not enough, because what happened with the GPUs is there's also another challenge. And that's the challenge of the complexity of configuring all of the supporting software infrastructure to make ML engineers productive. And I think probably all of you here in this room understand this pain, which is there's always new successive generations of the GPU. There's always new successive generations of the driver. There's always new successive generations of PyTorch or TensorFlow. And when you add up all of these things, it becomes an overwhelmingly difficult complexity to actually configure the environment so that the ML engineer can actually just spin up their notebook and actually start coding and getting their job done. Now, we here at Vultr believe every single ML engineer should be able to get up and running with the cluster that they need and be productive coding in their notebook within 20 seconds or less. That's our goal. Taking away the weeks and setup and complexity of managing the actual configuration of the GPU environment
No point in time should an ML engineer have to be a systems engineer, have to be a network engineer. In the persona for an ML engineer, I do personas for a living, amongst other things, in their jobs to be done description, where does it say that the ML engineer is a network engineer, is a storage engineer, is a systems engineer? They're not. They're ML engineers. So what you have to do is you have to take away all of this pain and complexity so that you can make certain that ML engineers, in as little as 20 seconds, can actually start making sense of the data and getting their job done. 20 seconds or less, that should be the goal. Just like every other web developer can actually begin coding JavaScript and throwing serverless functions to the edge, so too should an ML engineer be able to get up and running, start coding, and start sending serverless models to the edge. Wouldn't that be magnificent? Why can't we make that possible? We explore all this art of the possible with ChatGPT and new prompts all day long. I believe that the real art of the possible is let's give the power to ML engineers to be able to be as fast building, testing, and deploying to inference their own trained models close to the edge, just like we enable for web developers to be able to get up and running, type some JavaScript and throw it out in the edge and have it serve the entire worldwide population. That should be our goal. That is our goal here at Vultr. And we will, of course, make it happen. Now, when we're talking about a global application architecture, again, in this mad rush for large-scale training clusters using the H100, people still haven't lost sight of what do you do next. So great, I can spin up H100s in the clouds. I don't need to worry about reconfiguring my whole data center and spending 2 years to figure all that stuff out. Great, my ML engineers can be productive in 20 seconds. They don't have to spend 3 weeks actually setting up their environment to actually do productive work. But what comes next? Global application architecture. You don't just need to have one training cluster. You have multiple business units. You have multiple teams. Maybe your team doesn't live here in San Francisco. Maybe your team is in Bangalore. Maybe they're in Tel Aviv. God forbid, maybe they're even in Miami, where I'm from. No one's in Miami, it's just sunny and beachy. But it's nice to visit. So what we believe here is we need to start thinking about how do you enable globally distributed teams? How do you set up multiple training clusters? How do you actually do tuning of your trained models on localized regional data sets? And then how do you also get them trained, tuned models out to the edge so you can run production inference? Remember, inference is the new web app. Inference must happen at the edge. If you think that there was challenges in cost and complexity of setting up and configuring one cluster for training a model, how about scaling that inference across every single country and every single major metro region on the planet? The good news is we've been working on that here at Vultr for many years. So when we think about actually building and scaling a global application architecture, one of the things that we want to be cautious of is we want to learn lessons from the past. And in the first era of web applications, we built monolithic web applications, standardized on big things like IBM WebSphere, and we had to throw that all away and rebuild them to make it more modern and modular in a RESTful application age. In the 2010s, we wound up building on Amazon, and then we wound up actually getting lock-in into Amazon's cost and complexity, and then we wound up having the famous Andreessen Horowitz trillion-dollar paradox, where we realized that actually the cost of cloud operations was preventing us from as startups and enterprises from scaling profitably. So much so that many people, including Tesla just a couple weeks ago, repatriated their workloads from the cloud to purpose-built data centers. So in this day and age, when we start scaling our generative AI applications, let's avoid, in the future, creating the $10 trillion paradox, where actually everything that we do is just calling a central AI service from one of the big hyperscalers, and we're locked in the stack all the way down to their Trainium or Inferentia chips. And our value add is nothing more than a limited user experience or community built around that user experience, and then we don't have any long-term sustainable technical differentiation at all. We're fully locked in and at risk of getting disintermediated at any time. That will happen. That is a real risk. Furthermore, It's also a risk that we cease the rapid pace of innovation that we're in. We here at Virtual believe in a rapid future of innovation in the chipsets from NVIDIA, from AMD, from Intel, innovation in LLMs. The explosion of purpose-built, open source LLMs is something that we need to accelerate. These LLMs are more compact. They have faster responses. They have lower costs over time. They enable domain-specific tuning. They're evolving more rapidly, and they give you more control over your destiny. They give you more control over being able to adhere to NIST standards for explainability, for meaningfulness, for accuracy, and most importantly, for knowledge limits. Knowledge limits you need to be in control of so we can make ethical use of AI, so open source and proliferation of open source, and leveraging innovation, leveraging an independent cloud, we believe is a real priority in this new decades-long shift in architectural styles. So we'll skip past this in the benefit of the slide, but we here at Vultr believe very strongly that in order to move fast, let's make certain that we can help you set up all of your training, tuning, and inference environment at global scale today, harnessing the power of every single open source LLM and enabling all of your ML engineers to be able to immediately source the large language model they need to bring their own data set to 20 seconds or less, start training and tuning that model and getting it out to 32 regions around the globe with increased access to making sure that your generative AI applications can go live. We believe very strongly in making certain that you can actually change the entire global application architecture for the enterprise, take all the lessons from earlier epochs and apply them to move faster, more safely, more securely, with greater control of your destiny. So we're here today to say, hi, we're from Vultr, and we're here to help. Thank you so much.